it's Mrs. Compton. We're going to start today with a notice and wonder. So I have a rectangle back here, and I want you to think about all the things that you can notice and wonder about this. All right, so hit pause right now. Okay, you should have hit pause. We're back, and I'm going to guess some of the things that you noticed and maybe some things that you wondered. So maybe you noticed that obviously it's a rectangle, right? And maybe you noticed that you could find the perimeter of the rectangle. Remember that the perimeter rim is something that goes around. You could find the measurement of the outside of the rectangle. So maybe you did that. And if you did do it, it was 38 because this is 13, 13, 6, and 6. You add them all up and you get 38, right? Right. Okay, so maybe you did that, and maybe you said, well, this side is 6 and this side is 13. You might have done that. Maybe you even split up this rectangle and you counted out how many squares there are inside. Did anybody do that? 6 and 13 aren't really friendly numbers for me to count by in my head. Maybe they are for you, but for me, I would split up one of these numbers so that I could find an easier way to count. So I'm kind of wondering how you would split up one of these numbers to count the inside measurement, which is the area. So I want everybody to hit pause right now, and I want you to think about how you might break this up to make it easier to count. All right, hit pause. Okay, I'm back. You should have been paused. You should be back. You should have a strategy. I'm guessing now. What did you break up? I'm going to guess that some of you probably broke up the 13. Did you break it into a 10 and a 3? Let's try that out. Let's break the 10 or the 13 into a 10. So let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we've got 10 here and 3 here. So it's actually kind of like what we did when we were younger with a number bond, right? When we were in our younger grades. So 13 can be decomposed into 10 and 3, and that is going to help us multiply. So we're still using those skills from first and second grade. Okay, so now how many squares are there inside of here? Well, my guess is you probably know 10 times 6. So, and if you don't, you can probably count by 10 6 times, right? Because it's 10, 20, 30, 40, 50, 60. So that move was, I'm going to write, I think I'm going to get my blue out. So this was 10. Can you see that? Barely. I got to get my darker blue out. 10 times 6. And we know that was 60, right? Okay, now I'm going to guess that some of you probably did 3 times 6, so 3 groups of 6 or 6 groups of 3, depending on how you're looking at it. So maybe you did that next. So that's this part right here. So let's see, 3 groups of 6. Now, can you see the orange? Yes. Okay, good. So 3 groups of 6 is 18. And maybe you decided, okay, so I have them in smaller chunks now. This chunk is 60, and this chunk is 18. And now I can put them together. So that would be 78. So I'm going to put those together, and that equals 78. Did anybody do that? I'm going to guess some people probably did. Actually, I think I'm going to move this up here right next to it so I can draw another rectangle down here and guess what you did. Okay, I'm ready to take another guess. So I drew another rectangle down here with the same measurements, 6 and 13, because I wanted to take another stab at a strategy. So I'm going to try to guess some of your strategies out there. I'm going to guess that this one happened, maybe. And then let's check this one out. Maybe you decided to divide up the 6. Did anybody do that? because maybe you thought I could use 5 as my friendly number. 6s are real close to 5, so that actually helps me out a lot. So I'm going to move this 6 just a bit farther so I can break it into a 5. Let's see, 1, 2, 3, 4, 5. And then one more. Okay, so I could do that because counting by 5s is fairly easy for me to do in my head. So I could do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. Okay, so that would be 65. Okay, so that part was 5 times 13, or 13 times 5, right? So let's write out 13 times 5. And we know that that was 65. We can prove it right there by counting those. Okay, so I'm going to put 65 in here. And now I'm also going to need to count these down there. And lucky us, it's only 1. Did anyone do that? So one group of 13. So one group of 13. Or 13 groups of 1. It just kind of depends how you're looking at it. It depends how you're cutting it up, right? So I think I'll do 13 groups of 1. That way I can keep it consistent. So I have my 13 there, my 13 there, and my 5 there, and my 1 there. And together that makes the 6. I think I'll do that. All right, let's change the color though. 13 groups of 1. Okay, so here we go. Right down here. So that would make 13. And I'm going to put 13 right there. And I'm going to add these guys together. Okay, so 65 plus 13. Well, I know 60 plus 10 is 70, and 5 plus 3 is 8. So my answer there would be 78. So we got the same answer as last time, so that's a good sign, right? Now, I broke up one of the factors each time I did this, right? So I actually used a property. So this is how many people solve in their head. They break apart a number and they multiply the smaller pieces. It's called the distributive property. Everybody say distributive property. Distributive property. That's when you break apart one of the factors and you pass it out, so in smaller pieces. So we broke apart the 13 here and we passed it out to the 6. And this time we broke apart the 6 and we passed it out to the 13. So that's called the distributive property. We can also write these guys in one other way. So I want you to look at this. So we wrote 10 times 6 plus 3 times 6. You can see that in my picture. I can also write it as 6 times, so 6 times, and then I broke up the 13 into a 10 plus 3 basically, right? So 10 plus 3 more. So 10 plus 3 more. So I can show how I actually broke it apart and we can match it back to the picture. Okay, so let's see. How would you How would you write the break apart for this one here? So think about what was broken apart. The 6 was broken apart. What was it broken apart into? 5 and 1. And we did 13, and then we multiplied it by the 5 plus the 1. So 13 times 5 plus 1. So can you match that back to the picture? 13 times 5 plus 1. It's all the same. The important part is we're thinking about friendly numbers to break our factors into. Our factors are the numbers in the multiplication problem. Don't forget that. Okay, so these all equal 78. Doesn't matter how you look at it. So that's the cool thing, because brains think about things differently. So I'm wondering how you are thinking about this. How would you break apart these numbers? You can tell me in the comments. All right, I'll see you for the next lesson. Bye.